Okay, tabular integration. Maybe in the last okay, we've been doing integration by parts. Okay, and this integral right here, this is a prime candidate for integration by parts. Okay, so, you know, already did my picks. You know me. I like to make my polynomial portion of this thing. You know, like the x raised to the power. That's usually a good place to start with your u. But basically what would happen is eventually we'd use our integration by parts and we'd end up with a integration of v du. Okay, so we ended up integrating negative, so somewhere in here we'd end up with eventually, you know, negative 4x to the third cosine x. Okay, well, we can take care of that. It's just that we'd have to use integration by parts all over again. Okay, and we'd have to keep doing it until this you know, polynomial portion went away. Okay, because the trig function will never go away. It'll just revolve between cosine and sine and whatnot. But this will never go away. Okay, so I mean, you could do it, but it would be just a major pain to just keep doing this. So what we're going to do is we're just going to introduce the tabular method. Okay, of integration. Basically, I mean, if you look here, you know, all our little substitutions here are just derivatives and integrals, right? Okay. I mean, think about it. You know, what do we do right here? We take the integral of this portion, and we take the you know, we take the deriv of this. Okay, so why don't we just write all these things down on a nice little table, and then we'll write them out, okay? And notice how, see, since every single time, you know, this, you know, we end up with a revolving sign as well. Well, you'll see it. Now, when I say sign, I'm talking about the plus or minus, but just watch me write this down, okay? And I think you'll appreciate this method. So let's just go. I better write the original integral down. Okay, I'm going to remove this sheet right here. I'm going to go with the new one. Okay, so here we go. So the method for doing this is it's quite simple. Okay, so we'll just write down. Let me get a fine pen. Okay, here's a sine x. So we're looking for integrals over here, and we're looking for derivatives over there. Okay, so let's just go down the line. So it's just 4x to the third. That's just 12x to the second. 24x. And then 24. And then the derivative of 24, that's just 0. Okay, derivative of negative cosine will give me sine. Okay, and it looks like, let's see here, negative sine x. So I got negative sine x right there. What'll give me cosine will give me that. I'm just integrating sine of x, you know, and then integrating repeatedly. Okay, and then it looks like I end up with a derivative of sine is cosine. So let's see here. All right, I think I'm good right there. Just counting my stuff. Okay, so the next thing we're gonna do is we're gonna make a diagonal connection. We're gonna connect all these guys together. Right there. Okay, see how I did that? And I didn't get so diagonal. If you write it down on your notebook paper, it'll be a little better. So next thing we need to take into consideration, we just need to write this down. We're just going to jot down this alternating sign convention right here. Okay, and now the next thing we're going to do is we're going to multiply this thing by this thing. Okay, but we're going to do it in a special way, and I want you to watch me do it. Okay, so the first thing, that's just negative x to the fourth cosine. So that is negative x to the fourth cosine x. I'm going to put it in parentheses. I'm going to put a little gap, and I'm going to start a new parentheses. I'm going to multiply negative sine x times 4x to the third. So that's just negative 4x to the third sine x. Okay, and I'm going to put another gap in here. I'm going to have, what? I'm going to have 12x squared cosine x. I know I'm going to run out of paper here. Dang it. Let's see here, 24x sine x. I'm going to pan over a little bit, and I'm going to do a method I've never done before. I'm just going to keep this going on the next page. So, I mean, you should have this written down anyway. So 24 negative cosine x, that's just negative. My next deal is just negative 24 cosine x. Okay, I wrote it over here. So notice, let me see if I zoom out a little bit. That way we don't get too carried away. Okay, so notice how I multiplied each one of these together diagonally. So really you'll actually skip the first thing you integrate by. Okay, and you also skip the last thing you differentiate because it's just going to be 0. And now we're going to assign all these pluses and minuses. So the first term, the plus applies to the very first term. So I mean, it's kind of trivial, but we'll just put it there anyway. The next one is going to be the minus, so we'll stick the minus in there, and they just alternate. So let's just go in and fill the whole thing in right there. Okay, now if we simplify this, you know, of course, we're going to notice that, you know, the negative sign takes precedent. And then we're subtracting a negative value, so that turns positive. And then, well, this just stays positive. Cosine x, and that goes negative. And looks like this goes negative as well. Okay. Don't forget to tack on the plus c. Okay. I don't know if you can see that. Let me zoom in a little more. Shit. But notice how, see this expression right here? See how the derivative, the x, I mean, this is originally what we were doing, right? With our original u substitution and the dv integration by parts formula. Okay, and if we use repeated integration by parts, eventually we'd end up with this mess right here. Except it would be like a mess to the 10th power. I mean, it'd be huge. I mean, and you're guaranteed to make a mistake, you know? I mean, I make mistakes just adding. I mean, let alone doing an integration by parts, huge thing. So, I think this is going to be a good method for you. And usually the tip-off, I mean, right away, you can look at one of these things and you'll be like, okay, here's a polynomial, here's a trig function, something that'll never grow away, e to the x. You know, put an e to x in here instead of sine x. I'd go for it there. Say there was a natural log or something like that instead of the sine x. I'd go for it again and try it and see what goes on. So that's basically what I got, you know. So and it's really easy to do. Just take, you know, like I said, you know, we differentiate this portion, we integrate this portion. We write them all down, we neglect the first one, so that kind of puts us in the diagonal thing. Okay, so just multiply all these terms together. I would just write them out in parentheses like I did, that way you don't get confused, and then fill in the signs later. Okay, so I want you to go and rock and roll with that. I want you to go melt some faces and just destroy some integrals with that knowledge that you've just acquired. Okay, and thanks for watching, of course.